basically what they're wanting you to catch from lesson 1. In lesson 1, and we're going to combine a couple of these lessons here because they're not complex skills. There's just a few things that I want you to make sure that you understand in order to help check for reasonableness whenever you're dividing. Okay? The first lesson, if you look on page 122 in your textbook, it talks about using patterns to divide. Textbook 122 says using patterns to divide. And what it's talking about, if I see 18 divided by 9, we all know, since that's a basic math fact, that that's equal to what? Maybe we don't all know. What is 18 divided by 9? 2. Okay? And when we think about multiples of 10, I know that 18 times 10 is... Are we distracted? What's going on? What is 18 times 10? Okay. What is 90 times 10? 90. Okay. 9 times 10. I might have given you the answer. I don't know. Okay. So when I think about 180 divided by 90, I still take 18 divided by 9 and get 2. This 0 is going to cancel with this 0. So my answer is 2. If I have 1,800 divided by 90, I'm still going to look at my non-zero digits. 18 divided by 9 is 2. This 0 cancels with this 0. How many zeros do I have left over? My answer is 20. So if I took 20 times 90, I better get 1,800. Would I? Okay. Yes, I would. 2 times 9 is 18, and I have 2 zeros, 1,800. Okay? Some of you are still in left field. Put your PBL lessons away. Put everything else away. Okay? What if I have... What is this equal to? Yeah, I still take 18 and I still divide it by 9, which is 2. Then I have 2 zeros. I don't have any zeros here, so they can't cancel each other out. I add 2 to the end. Okay? That's all they're trying to get you to notice in lesson 1. So if I give you the example problem of what does that equal? 35,000 divided by 70. Hayden says 500. Let's check Hayden's math. He says he's going to take 35 and divide it by 7, which gives me 5. This 0, this first 0 is going to cancel with the 0 in 70. I have 2 zeros left that are unused. I'm going to add them to the end. Why does this work? Does anybody know why it works? But why? We're dealing with multiples of 10. So I'm thinking of this, if I would rewrite this number here. I have 35,000 tens. And I divide it by 70,000 tens. You have to think of it in multiples of tens. And understanding that each number to the right or to the left, so if I have, I don't know, let's just use all 5s. Okay, and you could use different numbers. You wouldn't have to use all 5s. Okay? So if I start here, would you agree with me that this 5 is in this first 5 is in the ones place, right? This second 5 is in the tens place, right? So if this 5 has the value of what? It's in the tens place, but it has a value of 50. So would you agree that 50 is a multiple of 10 larger than 5? Yeah, because it's 5 times 10, right? Okay, this 5 is 500. That's still 50 times 10. Okay, this 500, this is still 500 times 10 to give me 5,000. So everything is a multiple of 10. Okay, same if I go down. Instead of being a multiple where I'm multiplying by 10, I'm dividing by 10 as I go down. Okay? That's not the important part I want you to learn from this lesson. I want you to see the relationship between dividing when a number has zeros. Okay? All right, let's flip to lesson 2. Lesson 2 is estimating. So we're going to skip it because we're going to go to lesson 4. When I look at lesson 4, or I'm sorry, I'm going to tie estimating in with tomorrow's lesson, actually, not today's lesson. Today's lesson is dividing by multiples of 10, and we could estimate too whenever we do this. Let's look at our first problem. It says 249 divided by 20. Okay? When I look at this number, I can estimate 249 to be what?
250.
I could estimate it to be 250. I could also estimate it to be 240 if I wanted to. When I think of this being 20, and I know my multiples of 20, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, I might want to estimate it to be 240 because I'm dividing by 20. Okay? How many times does 20 go into 240? Well, how many times does 20 go into 100? 20 goes into 100 5 times. 20, 40, 60, 80, 100 5 times. How many times does 20 go into 200? 10 times. Okay? Then I have 240. So how many more 20s can I get in there?
2.
So now I have a total of?
221.
So there's, I'm sorry, that's not what I wanted to write. There's 5 20s in 100. 10 20s would get me to 200. I need to get to 240, so I have 12 20s, right? I could estimate this answer to be about 12. Okay? Because if I would estimate this to be 240, 20 goes into 240, how many times, Lana? 20 goes into 240. So if I was estimating 249 divided by 20, I could estimate it to be about 12 times. That 20 would go into 249 about 12 times. Would you agree? Because 12 times 20 gives me 240. Okay? So it should be reasonable to assume that my answer is going to be around 12. Give or take some. Okay? Now, how do I do the actual math? So our estimated answer is going to be 12. I know I lost some of you. We'll do another one, don't worry. Okay? Now I'm going to do the actual math. Have you guys done 2-digit divisors? No. You do it the exact same way. Your numbers just get a little bit bigger. Instead of having just 2 here, where I have to put 2 into 249, now I just have to put 20 into 249. Okay? So I have to ask myself, how many times does 20 go into 2? 0. I put my 0 above the 2. How many times does 20 go into 24? 1. I'm putting my 1 right above my 4. 1 times 20 is what? 20. Subtract. Same process, folks. You're still multiplying, bringing down, and subtracting. 4 minus 0 is? 2 minus 2 is? 0. I still have to bring down. How many times does 20 go into 49? Put my 2 above the 9. 2 times 20 is? I have to subtract. I get 9. Do I have anything left to bring down? No. So my remainder is 9. So my actual answer of 12 remainder 9 is pretty close to my estimated answer of 12. Pretty reasonable, right? Now, if I would have got an estimated answer of 26, one of these is going to be off. Okay? That's what estimating is going to help show you. It's going to help you understand if your actual answer makes sense, if it's reasonable. Does that make sense? Yes. I can't get past 20. Because if it was 20 or 21, it would go in there again. For example, let me just show you. Let's say right here, when we get to 49, let's just pretend that I said it only goes in there one time. 1 times 20 is 20, right? And if I would subtract, I would get 29. This remainder can never, ever, 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 ever be bigger than that number, than my divisor. Yes, absolutely. If you ever get a remainder that is bigger than your divisor, you know you made a mistake. Okay? And usually that means that this math was off and it just goes in there one more time. Okay? Does that make sense? Alright, let's try one together. So if I have is my divisor, and inside the box is 465. Okay? I follow the same steps. I just have 2 digits out here instead of 1. I just have a 2-digit divisor. Does 30 go into 4? No. Do I have to put that 0 above 4? I don't have to, but I can. Okay? So you can put that 0 there if you want to. Now I have to ask myself, does 30 go into 46? It goes in there how many times? 1. 1 times 30 is 30. Now I'm going to subtract. 6 minus 0 is 6. 4 minus 3 is 1. Now I have to bring down my 5. Now I have to figure out how many times does 30 go into 165. This is where your divisibility rules will start to come in handy. Promised you there was a purpose. Okay? If I don't know, I'm going to go out to the side and I'm going to do some guessing and checking. Okay? So let's say I start with 300 times 4. I'm sorry, not 300, 30. That gives me 120. Right? Okay? I can go higher because my number is 165, so I might take 30 times 5. 30 times 5 gives me 150. I'm trying to get to 165. Do I have room to put in another 30? Absolutely not. So, 5 goes above the 5 that I carried down. 5 times 30 gave me what? 150. Okay, 5 minus 0 is? 6 minus 5 is? Do I have anything left to bring down? Is my remainder smaller than my divisor? Yes. So I have 15, remainder 15. How could I check this answer? Yes. Take my whole number in my quotient, multiply it times my divisor, and add my remainder. Here's one for you to try on your own, which will be your ticket to your homework.